Okay, here's an Alex problem discussing the molar heat capacity is what we're going to be talking about in this problem. Okay, a chemist carefully measures the amount of heat needed to raise the temperature of a 429 gram sample of, this is aniline, C6H7N, from 27.6 degrees C to 42.1 degrees C. The experiment shows that 1.23 times 10 to the 4th joules of heat are needed. What can the chemist report for the molar heat capacity? Well, given the right equation, we can probably do anything, and the equation that's going to be we're going to be looking at is that the molar heat capacity C is going to equal then the heat, which is going to be Q that we're talking about, divided by the number of moles times the change in temperature. Okay, so we have heat that we're talking about. I can put that here in the denominator. The number of moles, when I give a mass, and I can calculate the number of moles just by looking up the molar mass of aniline or calculating it. And the change in temperature, I can calculate that as well. So let's go ahead and start off with the number of moles. So I have 429.0 grams of aniline, C6H7N, and I looked that one up, and there are 93.12 grams of aniline in 1 mole of aniline. And so when I do that math, then I calculate, rounding 4.61, I calculate that many moles of aniline. Okay, so I have this, I just calculated N. What about the change in temperature? Well, delta T equals the final minus the initial. So the final in this case is 42.1. The initial was 27.6. And so when I do that math, then I get 14.5. So I got 3 sig figs. This one I should have had 4, but it's going to be these 3 sig figs that looks like are going to dominate. I also have 3 sig figs right here. Okay, so there's my delta T. So now let's calculate that molar heat capacity. So the molar heat capacity equals Q, which in this case is 12300. That is joules. Okay, I just took that out of scientific notation. And I'm going to divide that by the number of moles, which I calculated to be 4.61 times delta T, which is 14.5. So when I do that math, then I get 184 with some zeros after it. 3 sig figs are going to guide this, and so my answer for the molar heat capacity is 184 joules per mole per degree. They want it in degrees Kelvin. I understand that this was in degrees Celsius, but delta T in this case, the change in temperature for degrees Kelvin or degrees Celsius has the same unit associated with it. So in this case I am able to use degrees C, and that I can report that still in units of inverse degrees Kelvin. So there is my answer to this problem for the molar heat capacity of aniline.